go ahead and open your book to page 54. We are starting lesson 4.2, still dealing with absolute value, but instead of equations this time we have inequalities. So lesson 4.2. Solve absolute value inequalities and then graph solutions of absolute value inequalities on a number line. So remember the marching band lineup? We're going to look at it again. Okay. So which people in the lineup are 3 or fewer units from 0? 3 or fewer units from 0. And I want you to write down all of their names. So when we were solving absolute value equations, or when we were looking at names, we only had 2. I have 5 here. 3 or fewer units from 0, so that's quite a bit. Okay, so let's show this portion of the number line that are 3 or fewer units from 0. So draw on your number line. I'm going to put 0 in the middle. Three or fewer units from 0. So 0 is our starting number. And we're going to move 3 units, 1, 2, 3, to the right. And I'm at 3. Go back to 0, 1, 2, 3 units to the left, and we're at -3. And it says 3 or fewer. So 3 is included. 3 units away. So close your circles at 3 and -2, 3 and -3. And then or fewer means that we're going to shade. Okay, so think about, where was Mara standing? What about Israel, Laura, and so on? They're standing along here from -2, -1, 0, 1, and 2. So we're shading in the middle. So if we look at this graph can be represented by an absolute value inequality. So this inequality right here, the absolute value of x is less than or equal to 3, represents the numbers on the number line that are 3 or fewer units away from 0. And how do I know it's 0? Because there's not a number inside my absolute value bars with the x. Okay, so look at your sign. It's less than or equal to 3 units away from 0. So what I would like you to do is, for question 3, circle the numbers below that are solutions to that same inequality. Which numbers are 3 or fewer units away from 0? And I want you to circle them. So we should circle -1 because we shaded that. We had a closed circle at 3 in our graph above. 0.5 counts. 4 does not. It's outside. And -3.1 is also outside. It's more than 3 or fewer units away from 0. Okay. So how many solutions does the inequality have? Well, honestly, it has a lot of answers. Okay, think about, there are a lot of decimals between -3 and 3. Or we could use the word infinitely many solutions. Question 5. If you were to write a compound inequality for the graph of, still dealing with the same absolute value inequality. So the absolute value of x is less than or equal to 3. And we sketched this in question 2. We talked about it in question 3 and 4. Do you think this would be a conjunction, which is an and inequality, or a disjunction, which is an or inequality? And then please explain why. Go back up to your graph in question 2. So this is a conjunction. Good job. Oops, let's switch. Conjunction. Which a conjunction is an and inequality. And how did you know that? Good, because we shaded in the middle, or we shaded to connect in between our two endpoints. How else do we know? Yeah, we were talking about a range of numbers. Everything in between -3 to +3. Good. You're going to have to turn your page to 55 for question 6. Okay. Let's write a compound inequality to represent which numbers are solutions to this inequality here. So let's write a compound inequality. We know it's going to be a conjunction. So it's going to be one big condensed or connected problem. And we can go back and let's look at our graph. What's my minimum here? Or my lowest number, my endpoint on the left? -3. And what's my maximum or my highest number? +3. So -3 comes first, then +3. And because we're shading in between these, we're going to put x in the middle. Remember, our signs face the same way here for conjunction. So x is greater than or equal to -3. And x is less than or equal to a +3. So this is a conjunction. Question 7. What numbers are more than 4 units away from 3 on a number line? My starting number here is 3. And we need to move 4 units away. So let's go 1, 2, 3, 4 to the right, 4 to the left. And it says more than 4 units away. This is exactly 4 units right now, so I have to leave my circles open because I need more than 4. So let's think about where we shade. How far away is 2 from 3? That's only 1 unit away, so that's not an answer. Okay. What about 9? 1, 2, 3, 4, 5, 6. That's 6 units away. That's more than 4. So we're going to shade to the right. Then over here, we're shading to the left. Ooh, what do we call this? This is a disjunction based on the graph. Good job. So the absolute value inequality that's right here for us represents this graph above in question 7. So a greater than symbol indicates that our distances are greater than 4 units away. So this is saying which x values are more than 4 units away from 3. So remember, this is how many units away we move, and this is our starting point, or our starting number. So go ahead and circle for question 8 the numbers that are solutions to the inequality. Numbers that are more than 4 units away from 3. .1. 7 doesn't work because we had an open circle. 0 doesn't work. We shaded over -2, so that works. 6.9. Nope, that doesn't work because 7 doesn't work and that's smaller than it. And 100 works. So all of these numbers are greater than 7, or these numbers are less than -1. So based on the graph in question 7, if we were to write a compound inequality, would it be a conjunction or a disjunction? So go back up and look at your graph in question 7. This is a disjunction. How do we know that? Because of where we shaded. We shaded opposite directions or opposite ways. We shaded outwards. We shaded apart. They're disconnected. And because it said more than 4. All right, let's take a look at question 10. We're going to start solving this just a little bit, and we'll get into solving later on as well. In order to solve this, we need to write this absolute value inequality as a compound inequality. So what that means is I need to write this as a conjunction or a disjunction. Remember, conjunctions is one big connected or condensed problem together, and then a disjunction, we always use the word or to separate those two. Okay, so just like we did with absolute value, okay, we need to isolate first and then drop our bars. So we know that this is a disjunction because we talked about it in questions 7, 8, and 9. So let's just drop our absolute value bars. So we have x minus 3 is greater than 4, and it tells us greater than 4. Or less than -4. So remember, when we were solving inequalities, if we have a negative, if we were dividing or multiplying by a negative, we had to flip or switch our inequality sign. So if I'm making this a -4, I need to switch my sign to a less than. All right, solve both of these under question B. Pause the video. These are two separate inequalities, so we're going to solve them separately. We solve them both the same way, though. So if I draw my lines down to keep myself balanced and organized, add 3, we get x is greater than 7, or add 3 again, x is less than -1. This is our answer here, but then it says to graph the solution. So let's draw a simple number line. We have an open circle at 7, and all x values are greater than that, so we're going to shade to the right. We have an open circle at -1. We need all x values less than that, so we shade to the left. Now wait a second, this graph matches, this graph in 10b is identical to what we did in question 7. Page 56. We're going to finish with 11 and 12. So make a graph that represents the answer to each question. That's our first thing we need to do. So let's make a graph. What numbers are less than 2 units from 0? So I'm going to start with 2 in the middle, or 0 in the middle. I'm going to go 2 units away. Less than 2 units from 0. So start at 0. We're going to go 1, 2 to the right. Start at 0, 1, 2 to the left. Notice it just says less than 2. It doesn't say 2 or less, 2 or fewer. So we need to keep our circles open here. Is 3 less than 2 units away? No, it's 1, 2, 3 units away. So that doesn't work. Is 1 less than 3 units away? Negative 1? Yes, so we're going to shade in the middle to connect these. Oh, I noticed this is a conjunction. We're not done yet because this next set of directions is write an absolute value inequality that has the solutions that are graphed. So what we're going to do is put our absolute value bars again. And it would be x minus my starting number, but my starting number is 0 here, so I'm not going to write x minus 0. How many units away did we move? 2. And we needed less than that. So less than. What numbers are less than 2 units away from 0? Now it says, finally, write each absolute value inequality as a compound inequality. So we're going to write this as a conjunction. So on the left, our minimum is negative 2. Over here on the right, we have a positive 2. Put our x in the middle. We are going to drop in our absolute value inequality signs here. So we need x is greater than negative 2, but x is less than 2. So here's my graph. I have my absolute value inequality, and then I have my compound inequality, which is my conjunction here. So why don't you just try B and C, pause the video. You can at least draw the number line and graph. Put 0 in the middle. That's our starting number. And we need 4 or more units away. So I'm going to start at 0. 1, 2, 3, 4. 1, 2, 3, 4. And it says 4 or more, so I know that 4 is included. Is 2 more than 4 units away? Nope. So I'm going to shade opposite directions or outward, apart. Notice this time we have a disjunction. So let's start with our absolute value bars. X minus our starting number, but this time it's 0, so I'm not going to write that in. How many units away did we move? 4. And then we were 4 or more. So our x values need to be greater than or equal to 4 units away from 0. Okay. So let's write this as a disjunction without our bars. So x is less than or equal to negative 4. or x is greater than or equal to 4. Question C. If you haven't already done so, pause, graph it, and try it. We're starting at -2. 4 or fewer. 1, 2, 3, 4. 1, 2, 3, 4. And because it says 4 or fewer, I know that 4 units away is included, so let's fill in or close our circles here. Or fewer, so we're going to shade in the middle. Ooh, conjunction. They're connected. And let's write our absolute value here. So x minus, what was my starting number? -2. But we know that 2 negatives make a positive. So we can turn this into x plus 2. Our units away were 4. But we were moving fewer units away, so make this a less than symbol. And then or equal to, because we closed our circles. And now let's write this as a conjunction. So I have a -1, 2. Oh, I skipped numbers here. Whoops. Sometimes that happens on a Friday. So this should be -6. I apologize. So -6 is our minimum, our first number. Hopefully you all caught my mistake. Our highest number is 2. X is in between those. And x is greater than or equal to -6, and x is less than or equal to 2. All right. Question 12. Describe the absolute value inequalities as conjunctions or disjunctions. So if I look at this first one, the absolute value of x less than 3. So this is asking you which x values or what numbers are less than 3 units away from 0. And because this is a less than, this means that we're talking about numbers between -3 and 3. So this is a conjunction, because we're going to shade in the middle to connect between -3 and +3. Look at your less than sign. We're going to shade together in the middle. So the absolute value of x greater than 3. So which x values are more than 3 units away from 0? So that means numbers that are farther than 3 units. So if I'm shading farther than, we need to shade out opposite directions. So this one is a disjunction. Notice we have a greater than symbol. Right here, greater than. We're going to shade out for a disjunction. And this is where we're going to stop for today.